everyone, I am Dr. Naresh Kumar, Assistant Professor in the Department of Electrical and Electronics Engineering, Institute of Aeronautical Engineering, Hyderabad. Today, we are going to discuss about Thevenin's theorem and its related problems. So, first, the statement for Thevenin's theorem. So, in a linear network, total number of sources, number of all voltage sources, current sources and resistors are replaced by single equivalent circuit. The single equivalent circuit consists of one voltage source in series with resistance. That is a Thevenin's theorem statement. If you see this statement, Thevenin's theorem states that equivalent circuit, that single equivalent circuit can be replaced by single equivalent linear network. In a linear network consisting of number of voltage sources and current sources and resistors, voltage sources and current sources are replaced by single equivalent circuit. That single equivalent circuit consists of only one voltage source in series with resistance connected across the load terminal. This is Thevenin's theorem statement. Now, suppose this one is one network. So, in this network, R1, R2, R3, R4 and R5 are resistors and V1, V2 are voltage sources. So, from this statement here, this circuit. So, this circuit here, if suppose I want to calculate the current flowing through the R3 resistor, IR3. Now here this R3 resistor is the load resistor, RL. RL means where you want to find out the current. So that RL is the load resistance. That load resistance can be calculated using the single equivalent circuit. That single equivalent circuit consists of voltage source in series with resistance. So first remove this load resistance and remaining circuit is replaced by single equivalent circuit. That single equivalent circuit consists of one voltage source in series with the resistance and reconnect the load across the load terminal. So that single voltage source and resistor in connected in series. Now here V1 and V2 are this network voltage sources. Now from this we can easily determine this is single loop circuit. We can easily determine this RL. RL means R3. R3 is the load resistance. Here you can calculate the IR3, that equals to IRL. Now here this IRL. Now here this IR3 current and this IR3 current is same. This circuit and this remaining circuit is same if these two currents are same. This circuit is replaced by this linear network consisting of number of resistors and voltage sources, and if suppose a current sources also can be replaced by single equivalent circuit. That single equivalent circuit consists of one voltage source in series with resistance connected across the load terminals. Now here if we know the RL value in which we have to calculate the current. We know the RL value. So RTH and VTH. So there are to determine RTH and VTH. There are steps. So to find out the RTH. So step 1 is first remove the load resistance from a given circuit and all voltage sources are replaced by short circuit. Voltage sources are replaced by short circuit and current sources are replaced by open circuit. Then calculate the equivalent resistance. That equivalent resistance is known as the RTH. So now first step is first remove the load resistance from a given circuit. R1, R2, R4 and this is R5. Remove the load resistance. So next this one, this voltage source is remove the load resistance from a given circuit. Voltage source is replaced by short circuit. So remove the load resistance from a given circuit. We remove the load resistance and this shorting the voltage sources. These voltage sources are replaced by short circuit and if there are current sources are present in a network, that current sources are replaced by open circuit. So shorting the voltage sources and opening the current sources, and calculate the R equivalent between open terminals. That R equivalent is known as the RTH. This RTH can be calculated from these two steps. And if RL and RTH over next over here, VTH can be calculated. To find out VTH, same thing. So remove the load resistance from a given circuit. Step 1. Remove the load resistance from a given circuit. R1, R2, R4, R5. Remove this and calculate. If you remove the load resistance, there is a open circuit, and that open circuit voltage you calculate it. So calculate the open circuit voltage. Open circuit voltage is known as the VTH. VTH is this one. After getting VTH and RTH, then we can calculate the load resistance current. So now IL equals to this IL current, IL current equals to VTH divided by RL plus VTH. So now here this is the final current from the Thevenin's theorem. These are the steps. First, determine the load resistance in a given network. So load resistance means in which current is to be calculated, and first that circuit convert into the Thevenin's equivalent circuit. That circuit consists of voltage source in series with resistance connected across the load terminals, and in that RTH, that single resistance is known as the RTH, that Thevenin's resistance, and that single voltage source is known as the VTH. That voltage VTH means Thevenin's voltage. RTH can be calculated when remove the load resistance from a given circuit. All voltage sources are replaced by short circuit, and all current sources are replaced by open circuit, and calculate the R equivalent between the open terminals. That R equivalent is known as the RTH, and substitute in this. And VTH can be calculated when load resistance is removed from the circuit, and calculate the open circuit voltage by using any network reduction technique or any circuit analysis method by using mesh analysis or nodal analysis method. Now let us take one example. So in this first example, calculate the current flow into the 100 ohms resistor using Thevenin's theorem. So now this is the circuit. Over here 82 ohms, 150 ohms, 47 ohms, 100 ohms and 15 volts. This is the circuit. Here calculate current flow into the 100 ohms. So what about first step 1? So step 1, RL equals to 100. RL equals in which current is to be calculated. That current RL equals to 100. 100 we have to determine the current in a given network. Now first this circuit is replaced by single equivalent circuit. This circuit is replaced by, so except that circuit is replaced by single equivalent circuit. That single equivalent circuit, this circuit and this circuit both are same if these two currents are same, I100. So that single equivalent circuit is connected across the load terminal. Now here this RL equals to, what about RL equals to 100. So now this is 100 and this is 100. This current is same, means these two circuit must be same. How you will calculate the RTH and VTH? First I will determine the VTH. So VTH can be calculated when load resistance is removed from a given circuit. From this circuit, remove the load resistance and calculate the open circuit voltage by using mesh analysis or nodal, any network analysis method, circuit analysis method. So first here, so remove the, first to calculate the VTH. So first remove the load resistance from a given. First draw the circuit, given circuit. 82, 47 and 150. This is the 100. This is 15. So remove the load resistance from a given circuit first. Calculate the open circuit voltage VOC. That VOC is known as the VTH, and that VTH can be substituted in the single equivalent circuit. Now here this is plus and this is minus I1 and I2. here I2 current equals to 0. Why I2 current is 0 here? Because it is a open circuit. Open circuit current is always 0. I2 current is 0. Now here this I2 current equals to 0. If you apply KVL in the first mesh, from the mesh analysis I am calculating the VOC. If you apply KVL in this loop, so if you apply KVL, this is mesh 1 and this is mesh 2. This is mesh 1 and this is mesh 2. Now here in the mesh 1, 15 is the rising voltage and minus 82 I1, 150 I1 minus I2. And here in the second case, I2 equals to 0. I2 equals to 0 means that is open circuit current is 0. Now here from this we can calculate the I1 value. Now 23 I1 and minus 150 I2 equals to 50. If you simplify this and this value I2 value 0 means, so I1 equals to 15 by 232. And next, this second mesh equation 150 I2 minus I1 and this 47 I1, 47 I2 and plus VOC. This is plus VOC. Now here, or if you take it is minus and this is minus. Now here this I2 value is 0 and this I2 value 0. First calculate this I1 equals to 15 by 232. So from this, if you solve these two equations, you will get I1 equals to, so this one 150, this is I2 equals to 0. Same, the simplified equation for this one is minus 150 I1, 197 I2 plus VOC equals to 0. That is equation number 1 and equation number 2. If you solve these two equations, you will get I1 and VOC. So see that one, this one 15 by 232 is 0.0646 and VOC is 9.6 volts. So here we need only this much VOC. VOC is known as VTH. That VTH is known as this one. Now this VTH is 9.6 volts. Now calculate the RTH. So to calculate the RTH, first remove the load resistance from a given circuit. So now first draw the circuit. Remove the load resistance from a given circuit. Voltage source is replaced by short circuit. This voltage source is replaced by short circuit and current source is replaced by open circuit. Then calculate the R equivalent between open terminal. That R equivalent is known as the RTH. So this is 82, 47 and this is 150. So remove the load resistance from a given circuit, short the voltage source and calculate the R equivalent between open terminals. This 82 and 150 are connected in the parallel and again in series with 47. So 82 and 150 are connected in parallel and plus 47 means in series with 47. Next, so that simplified equation, so 82, if two resistors are connected in parallel, so in that case, so case R1 into R2 divided by R1 plus R2, 82 into 150 divided by 82 plus 150 plus 47, that equals to 100.048. So this is 100.00048. So this one. Now here this is 100. Now we have voltage source, single voltage source and single resistance and load resistance. Then we can calculate the current flowing through this RL value 100 ohms by applying simple KVL equation. So in that case VIL equals to this VTH divided by this total resistance VTH by RTH. So now this VTH by RL plus VT, not VTH, RTH. This is not RTH. This is not VTH. Now here this is 100.048 and 9.6 divided by this is RL is 100, this one, and this RTH, this one 100.048. That value is 0.048. That current is 0.048 means 48 milliamperes. Now if you apply mesh analysis for this particular circuit, you will get the same value for this current flowing through the 100 ohms resistor. By using Thevenin's theorem, current flowing through the 100 ohms resistor, so here this value is 48 milliamps and here 48 milliamps you will get. If you connect one ammeter here, you will get the same value, 48 milliamps in the ammeter reading. Ammeter shows 48 milliamps and here also 48. You can verify. This is our laboratory circuit. So the next second question, Calculate the current flow into the 3 ohms resistor using Thevenin's theorem. So first see the circuit, same circuit, same similar type of circuit. So in the previous problem, first same current flow into the 3 ohms resistor, current flow into the 3 ohms resistor. So this circuit is replaced by single equivalent circuit. That single equivalent circuit consists of one voltage source in series with resistance, and this is RL. This RL equals to, this is 3. This IRL, this RL, this I 3 ohms resistor, this I 3 ohms resistor. Now here first VTH and RTH you need to determine. First VTH determination so can be calculated. First remove the load resistance from a given circuit. So as discussed in the previous slide, previous problem, so same procedure. So remove the load resistance from a given circuit and calculate the open circuit terminal voltage using any network, any circuit analysis method, that means nodal or mesh. So first I am using here mesh analysis. So 20. So first I am drawing the circuit for VTH for calculator. This one. So this is 20 plus 4, 5. Next 5. This is 2, and this remove the load resistance from a given circuit. 3 ohms load resistance you need to remove and calculate the open circuit terminal voltage, that is VOC. So first in this 20 is the rising voltage, and 20 minus this is I1 and this is I2. I2 current is 0 because it is a open circuit. Open circuit current is always 0. That open circuit current is always 0 means here I2 current is 0 and I1. Here we have two number of meshes. I1 current is in clockwise and I2 current is in clockwise. This is 1 and 2. So 20 minus 4 I1 and 5 into I1 minus I2. This resistive drop is also minus. Now if you simplify this one, 9 I1 minus 5 I2 equals to 20. Now here second mesh equation, 5 into I2 minus I1, 4, not 4 into I2, 2 into I2, this one, and plus VOC equals to 0. What would be the equation for this? 5 plus 2 is 7 and minus 5 I1 plus VOC equals to 0. Equation number 1 and equation number 2. This is equation number 1 and this is equation number 2. This I2 equals to 0 and this I2 equals to 0. After solving these two equations, you will get I1 and I2. Here I1 equals to 20 by 9. Now VOC. So after getting I1, you will substitute in this. You will get I1 and VOC. VOC I1 equals to 20 by 9 means that is 2.22 and VOC equals to 11.11. This VOC is known as the VTH. Then you can substitute here. Now to find out the RTH, first calculate the R equivalent. So how you will calculate first? So remove the load resistance from a given circuit and voltage source is remove this load resistance 4, 5, 2. Remove this load resistance and calculate the R equivalent. Remove the load resistance from a given circuit. Voltage source is replaced by short circuit and current source is replaced by open circuit. Then calculate the R equivalent between open terminal. That R equivalent equals to RTH. So now here 4 and 5 are connected in parallel and again in series with 2. So now 4 and 5 are connected in parallel means, so two resistors are connected in parallel means, so R1 and R2 are connected in parallel means that in that case R equivalent equals to R1 into R2 divided by R1 plus R2. So here R1 equals to 4 and R2 equals to 5. So 4 into 5 divided by this is 4 and 5 are parallel combination and in series with 2. Now 4 into 5 by 4 plus 5 plus 2 equals to 4.22. Now this 4.22 is the RTH. So this RTH can be substituted here. Now RL we know here and RTH and VTH calculated from these two steps and then substitute here. This one is 11.11 and this one is 4.22. Now calculate the current value. If you apply, this is the IL. If you apply KVL in this directly, you will get IL equals to VTH by RTH plus RL. This is RTH. Now VTH by RL plus RTH, that equals to 11.11 divided by 3 plus 4.422, that equals to 1.53. This current equals to 1.53 amperes. Now here from the Thevenin's theorem statement, this circuit current equals to 1.53. Current flowing through the 3 ohms resistor using Thevenin's theorem is 1.53 amperes. Now third question. Third problem, calculate the current flow into the 2 ohms resistor using Thevenin's theorem. So now here we have two sources. In the previous two problems only we have one source, and here we have two sources. Here that according to the Thevenin's theorem, number of voltage sources, in a linear network containing number of voltage sources and current sources are replaced by single equivalence and number of voltage sources. Now here this circuit is replaced by single equivalent circuit. That single equivalent circuit is connected across the load terminals. Here what is the load resistance? Not 1. Here load resistance is 2 ohms. I 2 ohms resistor we need to calculate here. Now this is the I 2 ohms resistor, and this circuit is RL equals to 2 ohms resistor. Now this remove this, and this circuit is replaced by single equivalent circuit. Now here how you will calculate this VTH and RTH? Same procedure. If you follow the steps, that RTH steps and VTH, then you will get the same value. From the mesh analysis, you will get same value. Nodal analysis, mesh, and Thevenin's Norton's superposition theorem. Any method you will get the same value. First, I will determine VTH and RTH. First method, VTH. First, remove the load resistance from a given circuit. 7 volts, 28 volts, 4, 1, and this is 2. So this is the load resistance. Remove this load resistance and calculate that open circuit voltage. This VOC, that open circuit voltage, is known as the VTH, and substitute in this. So now here, so if you apply KVL in this open circuit current, this branch current is 0. This is I1, so mesh 1, and this is current I2, mesh 2. So now here there is no current here, so same I1 equals to I2 current. I1 equals to I2 current. If remove there is no current path here, it is an open circuit. So open circuit current is 0, means this I1 current equals to I2. This branch current is 0. Now if you apply KVL in the mesh 1, 28, I1, 28 is the rising voltage, minus 4 I1 minus VOC, plus and minus VOC. Now second case, 4 I1, if you simplify this one, 4 I1 plus VOC equals to 28. That is equation number 1. And if you that I1 equals to I2, this condition, and second equation 7 minus 1 into I2 plus VOC equals to 0. Now the simplified equation, minus 1 I2 plus VOC equals to 7. Now if you solve these two equations, you will get I1 and I2, VOC equals to 11.2. That is VTH. Now determination of calculation of RTH. RTH can be calculated. First draw the circuit. For this resistance is 2 and 1, 7 volt and 28 volts. Remove the load resistance from a given circuit. First one. Step 1 is over, and voltage source is replaced by short circuited. Is there any current source? No, there is no current source here. So short circuit. Voltage source is replaced by short circuit, and calculate this R equivalent. So how you will calculate R equivalent? Now here this circuit 4 and 1 are connected in series or parallel. So these two are connected in parallel, not in series. If these two terminals are connected here, that is series connection case. Now I am drawing this circuit. So open this terminal and this one and this one. So now this 4 and 1, these two are connected in parallel, not in series. So 4 into 1 divided by 4 plus 1. So 4 into 1 divided by 4. These two are 4 and 1 are connected in parallel. That equals to 0.8. So now we have Thevenin's voltage, and this R equivalent equals to 0.8, that is RTH. Now here we have RTH, VTH and RL value. Substitute here. VTH, this is R and this is 11.2 and 2, 11.2 and 0.8. So this is 4 ampere. Exactly 4 ampere. So this current flowing through this 4. This is 4 ampere and this is 4, not this. Here 4 ampere. And this current flowing through this one is the 4 ampere using Thevenin's theorem. Now next problem. Calculate the current flowing through 2 ohms resistor using Thevenin's theorem. Now here see this diagram. Here how many sources here? Total 3 sources. Already we calculated current response in using superposition theorem. So that thing we have also verified in the mesh analysis also. So same question, using Thevenin's theorem we are determining the current flow into the 2 ohms resistor for this particular circuit. So now let us verify that for Thevenin's theorem also. Now mesh analysis and superposition already verified. Now first, so same thing, the circuit is replaced by this 2 ohms resistor is a load resistance, and so the circuit is replaced by single equivalent circuit. That single equivalent circuit consists of one voltage source in series with resistance RL equals to 2 ohms resistor, in which current is to be calculated. Now here this RTH and VTH calculation. First VTH calculation. So to find out this VTH, so first this one, and this should be 10 volts, and this is replaced by 10 ohms and 20 volts and 5 and 40 volts. Now here this one. So calculate this open circuit voltage VOC. Calculate the open circuit voltage. So plus minus plus minus plus minus plus here. Now first remove the load resistance from a given circuit. 2 ohms is replaced, removed from the given network, and calculate this open circuit voltage. This is I1 mesh analysis using. I am using mesh analysis. 2, 1 and 2 are 2 meshes. I1 and I2 are mesh currents. I1 and I2 in clockwise direction. Now here if you apply KVL in the mesh 1, so now here minus 40 minus 5 I1, this voltage minus 10 I1 minus I2 minus 20. Next second, if the what will be the simplified equation? 15 I1, 10 plus 5 is 15 I1 and minus 10 I2 equals to 40 minus 20 is the 20. Now this is equation number 1, and equation number 2 is 10 I2 minus I1 plus VOC and this one minus 10. This is not minus I1. So this is a simplified equation. This what is the value here? So minus 10 I2 minus I1. So this is not 2 I2. This is minus 10 means, so plus 10 plus VOC plus and minus. So now here this is not 12 I2 plus 10. Now here this I2 current equals to 0. Here I2 current equals to 0. I2 current equals to 0. Now here I1 equals to 1.33 and VOC equals to 23.33. Now this VOC equals to VTH and VTH equals to 23.33. Now calculation of RTH. RTH can be calculated. Now here RTH equals to this one. So how you will calculate this RTH? All this one. Now here this voltage, this resistor is replaced by this one. This is replaced by, remove this load resistance and calculate the R equivalent. Now all voltage sources are replaced by short circuited, and this is 5 and this is 10. So these two are connected. 5 and 10 are connected in parallel. 5 and 10 are connected in parallel means 5 into 10 divided by 5 plus 10 equals, that equals to 3.33 ohms. 3.33 ohms, and this is volt and this is 2. Now we know the VTH, RTH and RL. So now here, so VTH by RTH, that equals to IL equals to this load current IL equals to VTH by RL plus RTH is equals to 23.33 divided by 2 plus 3 sorry, this is 3.33 equals to 4.38 amperes. So this current is 4.38 amperes and this current is 4.38 amperes current flowing through the 2 ohms resistor. This is 4.38 current flowing through the 2 ohms resistor using Thevenin's theorem, 4.38 amperes. From the mesh analysis superposition theorem also same value we got. Now next question, calculate the current flowing through 2 ohms resistor using Thevenin's theorem. So first, this is the circuit. So 3 loops, 3 meshes circuit we are taking here. 2 resistors, 2 volts, 4 volts, 2 ohms, 12 ohms, 1 ohm, 2 ohms and 3 ohms. So first this circuit is replaced. Where we have to find out the current here? Here current flowing through the 2 ohms resistor. Here only we need to determine. So first this circuit is replaced by single equivalent circuit. That single equivalent circuit consists of one voltage source in series with resistance connected across the load terminals. This here RL equals to 2 ohms resistor. Now calculate the VTH and RTH. First VTH calculation. So now remove the load resistance from a given circuit. First I am drawing the circuit first. This one. Two volts and 4 volts, 2, 12, 1 and 3. So remove this load resistance and plus and minus and calculate this VOC voltage. Plus and minus. Now this is the, how many loops here? 1, 2, I1 current, I2 current and I3 current. So 3 meshes are 1, 2, 3 and mesh currents I1, I2 and I3 in clockwise direction. So now apply KVL in the each mesh. Here this current equals to 0. This branch current 2 ohms resistor removed. Here this branch current is 0. So I2 current equals to I3 current. This keep it in mind. So at the time of calculation, now 2 into 2 is equal to minus 2I1, 12 I1 minus I2. So if you apply KVL in each mesh, algebraic sum of total voltages in a loop equals to 0. Now 2 minus 2I1 minus 12 I2, I1 minus I2 equals to 0. What will be the simplified equation? 14 I1. So 12 plus 2 is 14 and minus 12 I2 equals to 2. Next second equation, second mesh equation, if you apply KVL in the second mesh and 1 into I2 minus that one and 12 into I2 minus I1, that is also minus, and minus VOC, this one, equation number 1. Now the simplified equation, minus 12 I1 plus 13 I2 is equal to minus VOC. Now this is equation number 1, equation number 2 and third equation VOC, this plus VOC and minus 3I3 and plus and minus, this is that minus 4, this 4 volts. Now equation number 3. So now this is now if you solve this, I1 equals to I2 equals to I3 equals to I1 equals to minus 0.2, I2 equals to minus 0.4, I3 equals to also minus 0.4 because these two currents are same. Now VOC, we need only here VOC. VOC means that is 2.8, that is VTH. So VTH can be submitted here. We can submit here, substitute here 2.8 volts. Now here, next, calculation of RTH. Calculation of RTH. First, remove the load resistance from a given circuit. So first I will draw the circuit. Remove the load resistance from a given circuit. So first 2, 1, 3, 12 and this, remove the load resistance from a given circuit and voltage source is replaced by short circuit, and this voltage source is replaced by short circuit, and calculate the R equivalents. And 12, here 12 and, now see the calculation. So this 2 and 12 are connected in parallel and again in series with this 1 ohm resistor. Is this okay? And 12 and 2 are connected in parallel. This is parallel and this condition is series connection, plus indicates series connection. Again this entire circuit in parallel with 3 ohms resistor. Now here the simplified equation that equals to 1.43 ohms. Here 1.43 ohms means here this is 1.43 ohms RTH. Now we got the VTH, RTH and load resistance RL. We know the load resistance, so then we can calculate the IL. Now here VTH equals to IL equals to RTH, VTH by RL plus RTH 2.8 divided by 2 plus 4.3, that equals to 0.082. So now that this current equals to 0.82 and this current equals to 0.82 and current flowing through the 2 ohms resistor is 0.82 amperes. Now if you apply KVL, if you apply mesh analysis for this particular circuit, I1, I2 and I3, I1 minus I2 must be, that should be equal to 0.82. Now next, calculate the current flowing through the 10 ohms resistor using Thevenin's theorem. Now here this is the circuit, here current source problem. One current source and one voltage source. Current source value is, this is amperes, 10 amperes and this 100 volts resistor, and this one 5, 10, 20 and this one is 30 ohms. Now here the circuit is replaced by single equivalent circuit. Here where we are calculating, here this is the RL. This RL equals to 10 ohms. This RL equals to 10 ohms. So now here first calculate the VTH. How we will calculate the VTH? So first VTH can be calculated. So I1 equals to direct value. This is, so first I will draw the circuit. This is 10 amperes and this is 5 ohms and this is, remove the load resistance, and this one 100 volts, 30 and 20. So this I1 equals to, how many loops here? 1, 2 and 3. So this mesh current is I1. This mesh current is I1 and this mesh current is I2 and this mesh current is I3 in clockwise direction. Here I1 equals to 10 and I2 equals to 0 because it is a open circuit. Calculate this open circuit voltage. That open circuit voltage equals to VTH. So now I1 equals to 10 and if you apply KVL in this, minus 5 I2 minus I1 minus 20 I2 minus I3 minus V3. Here I2 equals to 0. So now third mesh equation. So if it's the simplified equation, this I2 equals to 0, minus 5 I1 minus 20 I3 equals to minus VOC. Now 20 minus 20 I3 minus I2 minus 30, this one if you apply KVL in the mesh 3. So this is equation number 1, equation number 2 and minus 30 and minus 100 equals to 0. Now here minus 0 I1, there is no impact of I1 current, and here I3 minus 20 I2 and 50. 20 plus 30 is 50, I3 equals to minus 100, equation number 3. solve these three equations. If you solve these three equations, you will get I3 equals to -2 and VOC equals to 10 and I1 equals to 10. I1 equals to 10 and I2 equals to 0. So this 10 volts here, this is 10 volts, and calculate the VTH. Calculate the VTH value here. RTH can be calculated. So remove the load resistance from a given circuit. So first remove the load resistance from a given circuit. This is 5 and this is 20. So now here there is no resistor here. Up to here 1 and here 1 resistor, and this is 30, and here this is the 10 ohms resistor. Now over here this is 10 ampere and this one is 100 volts. Now first step 1 is remove the load resistance from a given circuit, and voltage source is replaced by short circuit. This voltage source is replaced by short circuit, and this current source is replaced by open circuit. So this should be open. Current source is always open circuit, and voltage source is remove the load resistance from a given circuit, open the current source and short the load terminal, short the voltage source, and calculate the R equivalent. So how you will calculate? This 20 and 30 are connected in series. So 20 and 30 are connected in parallel and in series with 5. Now here that value is 17. So this one. So Thevenin's voltage is 10 volts and this RTH is 17 ohms. This is 10. Now calculate the VTH. Now RTH IL equals to this. IL equals to this. IL equals to this. IL equals to this. IL equals to 10 volts VTH divided by RTH plus RL, that equals to, now here 10 by 10 plus 17, that equals to 0.37. So this current equals to 0.37, this load resistance current, and this current equals 0.37, and current flowing through the 10 ohms resistor equals to 0.37 ohms using Thevenin's theorem. Same problems we will see using Norton's theorem. We will get the same values if you follow the Norton's theorem steps. So that we will see in the next lecture. So if you still have any doubts in the Thevenin's theorem, you can comment in the comment section below. I will answer to your queries. Thank you very much to you all.
Like, share and subscribe. Hit the bell icon for more updates.